Hello and welcome to another one of these ADD videos. Today we're going to look at the concept of Michaelis Menten kinetics. So in the early 1900s, when these two guys, Michaelis and Menten, got together, they looked at the reaction of the first part of the enzyme substrate interaction. And Briggs and Haldane, about 20 years later, gave them the refined version, including the enzyme to product portion of this reaction. So what the key is the formation dissociation of this enzyme substrate complex. Okay, so if we look at it from that perspective, keep in mind that just basic chemistry, the rate of a reaction or the velocity of a reaction is the rate constant K times the concentration of the reactants. So if I look at the velocity of formation of this enzyme substrate complex, and I, for now, just consider what's in green, I'd get enzyme plus substrate, the rate at which this complex forms, and the formation velocity or rate is going to be that constant times the reactants, which are substrate and enzyme. All right. So if we're looking at the dissociation, there's the dissociation if we're talking about going from enzyme substrate back to the reactants. That's this right here, and you use the corresponding rate constant times the reactants, in this case enzyme substrate complex. Here we have the velocity dissociation into the enzyme and product. That's what this is here, and that's the corresponding velocity. So if we're looking at rapid equilibrium, this is what you have to consider. Okay, we got to look at just the first part of this reaction, just this portion. Okay, and as a result, the rate of K1, the formation, must be much greater than the dissociation to enzyme product. Okay, and if Km approximately equals Ks, that's how you know you're in rapid equilibrium. Okay, these little conditions. So you might be given data to where you could calculate K1, K2, K inverse, Km, Ks. And then if these two are approximately the same and K1's much bigger than K2, then you know you have rapid equilibrium. And you can calculate K sub S by doing this or this, depending on what you're given. All right? So if we're looking at steady state, we know that the rate of enzyme substrate complex is pretty much constant, meaning there's no rate of change. And derivative is a rate of change, so that's why the derivative of the enzyme substrate complex was equal to 0. Here we have, I guess I wrote it somewhere. I could have sworn down there. Okay, so steady state is also whenever Km and Ks are not equal, and K2 should be big. All right. So if we did consider the whole picture, this whole thing, not just the first half, this would be the velocity of formation. That didn't change. But the dissociation portion has one extra rate in it. Okay, the dissociation would be calculated as the sum of the one that goes to the product and the one that goes back to the reactants. So if you calculate the sum, factor out the enzyme substrate complex that's common to both of those, you get this, and then that's where that came from here. Derivations aren't that important. This does give you the Michaelis Menten constant whenever you divide both sides by ES and K1. so you need that formula definitely. And with some algebra and the fact that velocity equals K2 times ES, and enzyme total is the free-floating enzyme plus the enzyme substrate complex. When you do that, you end up with the Michaelis Menten equation, manipulated around a little bit. Definitely have to know this one. Okay, I will do some example videos in which you'll need to calculate either Vmax or Km given data. So, interesting note, if this becomes equal to the square or the substrate concentration, you're going to get 2s down here. The s's will cancel, and then V will equal Vmax over 2. If you remember on the saturation curve, substrate saturation curve video, there was a point that was half Vmax was equal to a certain concentration. Well, this is why. So again, no, definitely the conditions for rapid equilibrium versus steady state. And basically the main difference is rapid equilibrium, they're saying that it forms but dissociates before it gets to product. And then the steady state is the enzyme substrate concentration does not equal 0. So I hope I've eliminated some doubts that you might have. Check out the example videos that pertain to these topics. This is where biochemistry starts to get a little bit more difficult for some people. So don't fall behind. Thank you and have a nice day.